So today's tutorial, we are covering scale level 2. Level 2 in particular, because this is where it gets a little bit more advanced, okay? Let's have a quick look. First with our aims and objectives. Fidelia just asked the question, how do I book for a practice test? We can do practice tests once you've finished all your learning. If you let me know when you are finished, I'll have a quick look on BKSP, see if there's anything I can advise you to work on a little more, or if it looks like you're okay on there, then I will send you a link to do practice tests. We don't do practice tests until you've finished all your learning and you're confident with what's on there, because we're aiming for passes on practice tests. But as the process goes, this is how I do it. Teresa might do it slightly differently. You do all your learning on BKSP along with my support with any other extra resources that you might need. Once you've gained full marks or strong marks in each of the skill checks on each of the topics at level 2, each of the 7 modules, that would prove to me and to you that you have in fact learned what you need to learn, and you are then ready to move on to practice testing. We've got different scenarios in practice testing. We have paper tests and we've got Open Assess, which mimics the actual City and Guilds exam. So I might send you a paper-based practice test to do first, because the first practice test can be a bit of a test just to see if there is in fact anything else that you need to work on, because when you've done all your learning on BKSP, particularly when you're on BKSP, you know what topic or module you're doing, but there's a little gap between learning and then applying what you've learnt in a practice test scenario. And in those practice tests, you might have to apply more than one piece of knowledge to answer the question. So that's why we do practice tests as well. For me, you'd be able to pass at least 2 practice tests to show that you're ready for the exam. If we do 2 practice tests, then obviously we've tried different scenarios, different types of questions. If I do 1 practice test, those questions in that 1 practice test might have suited you quite well, and then in the exam you might get lots of questions that you weren't prepared for or we've not practiced. So I'd rather do 2 practice tests. We have lots of different types of scenarios. If you can pass 2, obviously it proves to me and yourself that you are ready for that final exam. Is that okay? Just let me know if there's any other questions on that. So the aim today is to further understand how to interpret a given scale. The objective is to be able to answer questions related to level 2 scale. So what I thought we'd do, we're having a little recap on last week. Now, if anybody didn't get the recording of last week was scale level 1. And what I did last week was I showed everybody a method to work out scale, which everybody on the tutorial seemed to like. And obviously it's always worth being shown a different method, maybe to one that you've been shown on BKSP or that you've seen before. And because you're aiming to find something that suits you. So if that method suited you, that's great. And everybody seemed to like it. And then we did more practice using that method. So if you need a recording of last week's tutorial, just send me an email or drop it in the chat and I'll just pop your name down. I'll send you a recording of that. You'll also get a recording of this tutorial afterwards as well, once we've completed it and the recording is ready for me to send out. And then you could maybe watch the level 1 one and then follow that up with the level 2 scale tutorial together. Yep, Kerry's last one, that's fine. I'm just going to pop your name down, Kerry. So obviously I'm hoping, yeah, Sharon. I'm going to recap this just for anybody who didn't watch or see the tutorial last week. Please also remember, I just thought just popped into my head as well, please add to your session logs that you've attended today's tutorial. With your session logs, you add any type of learning, anything to do with maths whatsoever goes on your session log. So even if this is the only part of maths that you do today, you've got no time to work on anything else, add a session log once you've finished, once the tutorial's finished. Just add what we've covered and how it went for you. We need to record every single part of maths that you do. So obviously if I send you a tutorial recording to listen to, once you've listened to it, make sure you add that to your session log as well, alongside anything else that you're doing maths that day. We just submit 1 session log per day, but we bring that whole day together and make sure you include everything that you've covered in that session. Okay? So let's have a look at a recap. So last week we discussed how scale drawings allow us to draw larger objects on a smaller scale while keeping them accurate. All scale drawings must have a scale written on them, and scales are usually expressed as ratios. At level 2, you would probably find more ratios than the other way, which is where you've got equals in the middle. So for example, 1 centimetre to 100 centimetres. At level 1, you might see 100 centimetres equals 1 centimetre equals 100 centimetres, but at level 2 they're quite often written as expressed as a ratio. So the ratio 1 centimetre to 100 centimetres means that for every 1 centimetre on the scale drawing, the length will be 100 centimetres in real life. We're going to go back over that. Just give me 1 second. I'm just going to set something up on my BKSP because I'm hoping what my plan was today is to go through the learning elements of BKSB, because if you guys were, if COVID didn't exist and you were in the centre, that is exactly what I'd be going through with you, and then I'd be finding you extra resources. So if you were working through the learning section and you'd watched the video and you didn't understand it, I would be there to then explain it to you further. So what I thought we'd do today is kind of mimic that, go through the learning and hopefully answer the questions in the learning. And the aim for me is for you to then, if you have time, or the next thing you do on your learning is to then go and do that level 2 scale skill check. So if you haven't done the learning yet, you can go through it, because that's what we're going to go through today, the level 2 learning on scale, which is within the measure module, and then have a go at the skill check. So if you haven't touched scale at level 2 yet, you might want to, after this, go through the learning on scale. It's just like what we're doing today, and then have a go at that skill check and see how you fare with that. What my plan is next week, hopefully, is to then bring together the last 2 weeks' tutorials and look at some exam style scale questions. So we'll bring everything together that we've learned and see if we can apply it to some exam style questions. Because those questions tend to be the bigger marks, like 4, 5, 6 marks. So if I can help you with one of those questions, that's a lot of marks that we can get on one question. Okay. So if the scale given is as 1 to 500, what real life distance would be represented by 4 centimetres, 2 metres, and 8.5 kilometres? Now, I've just added this in here so I can show everybody the method that I went through last week, just in case you didn't attend or you haven't seen the recording yet. But if you want to, you can have a go. Just put your answer in the chat box if you know how to answer that question or any of those questions there. So what we have, I'll just briefly go over scale again. So what we have is a scale of 1 to 500. That means for every one on a plan, and that plan could be a diagram or a map or a drawing, every one is equal to 500 in real life. Okay? Now, if we have 4 centimetres, which one have you worked out there, Kim? If we had 4 centimetres, yeah, I know which one you mean. On the plan. So what we do, we add 4 here. So this 1 to 500 can be on any measurement, but it just means that for every one of something on the plan is equal to 500 of something in real life. So that could be 1 centimetre is equal to 500 centimetres. It could be 1 metre is equal to 500 metres. It could be 1 kilometre is equal to 500 kilometres. How we figure it out is by looking at the question and the type of measurements used in that question. So if on the plan we have 4 centimetres, what we need to do is figure out by how much we've increased the plan size. So as I said, a scale is there to increase and decrease the size of something in real life and not in real life on the plan. So what we've done here, how do we get from 1 to 4? We've increased the plan size by 4-fold, 4 times. So we do exactly the same on this side to keep to the scale. Whatever you do to one side, you do to the other. So if we've increased it 4 times this side, we increase it 4 times this side, and we get 2,000 centimetres. Fab, I've got some answers here. Yeah, Kim, thank you. 4,000, 2,000. So Tasneem said not 1 centimetre to 500 metres. No, it doesn't say that. Now, if it said that, if it said 1 centimetre to 500 metres, that would be different, but it doesn't. So because it's on the plan is this much, we're going to go with it being the same type of unit. So Fidelia's got, so lots and lots of chats. 2 metres. Fidelia, are you sure it's 1,000 centimetres or 1,000 of something else? Meters? The 4 centimetres. But again, nowhere there does it say that this is meters. What we have is a scenario of 1 to 500. So whatever it is on the plan, 1 on the plan is worth 500 in real life. If we're told the plan is in centimetres, then we would go with that in real life as well. What you might have is where they ask for the answer in meters, but you'd still work out the scenario in the same measurements, and then you would convert that into meters afterwards for the answer. It is, yeah, Tasneem says so. It always stays the same. It does unless it says differently, and this is the reason why I'm going to try and see if you can watch the BKSB video in a moment. We could all watch it together. So let's look at the next one. So this time we've got 2 meters on a plan, big plan. If it's 2 meters on the plan and our actual plan is 1 to 500, we've increased the plan size by how many? If we've gone from 1 to 2, what have we done to the scale? By how many have we increased it by? Yeah, exactly. So we've increased it twofold, twice. So we're doing exactly the same this side. We double it to get 1,000 meters. Unless it said, give me the answer in centimetres. Then you convert this into centimetres. Let's have a quick look at the next one. I do apologise. It's probably easier to write this out every time, which you can do. So we've got 1 to 500, and this time we have 8.5. So we've increased this side. Yeah, well done, Tasneem. We've increased this side by 8.5 times. So we've gone from 1 to 8.5. So we've increased it by 8.5. So we have to do exactly the same to this side. You times it by 8.5. You can use a calculator, but it's 4,250 kilometres, because that was kilometres. Well done, Kim. Well done, Pam. Well done, Tasneem. Well done, everyone. Did anybody, there's a lot of people on here. There's 10 people here now. So I apologise if I don't cover your name. But could anybody, is everybody okay with that? Because I've got a lot of chats with different answers on. Chloe said, was this be a calculator question, do you think? It could be non-calculator, if I'm honest. Even that one. If you look at that 500 by 8.5, you could do 508 times. Even if you wrote it like this. 3, 4, so you've got 2,000 there. So if you do that again, that's going to give you 4,000. Then half of that is 250. So you'd have 4,250. So it looks quite, it looks quite scary that, increasing it 8.5 times. But this is where your multiplication comes in. And Joe, I mentioned I might do some scale questions next week, because then you might have to use a bit of your other maths knowledge as well. Bring that together with your scale knowledge. But yeah, don't look at a scale. I think a lot of people can look at a scale and go, oh, wow, that's huge. I can't do that. You can. Yeah, I think Kim just said converting is the hardest. Yeah, it can be. I can even cover that next week as well if you want to. We can cover some converting, and we're going to do it today as well, because we need to go from centimetres to kilometres, which isn't too bad. I can show you. I can show you how to do that. Yep. So if I do some converting next week and then a couple of scale questions, maybe I think that might round it up quite nicely. Let me note that down. Yeah, is that okay? Yeah, Pam said she did 500 times 85 to get the answer, 42,500, and then she just ignored the last zero. Yep, exactly. There's lots of different scenarios you could do. So you've turned that 88.5 into 85, then you've knocked it, you've sort of times it by 10 and then decreased it by 10 by knocking the zero off. Whatever works for you. My mental arithmetic is much better than my actual written multiplication, division, and things like that. I'm not too bad with my mental arithmetic, so I don't always need to use those methods, but that's the sort of thing I would do mentally. I would maybe times that by something else, or do that method. As I said, if you do 508 times, and then half of 500, 500 times a half, you could get 4,250. Right, let's move on because we've got a lot to cover today. What I'm hoping to do, so you'll recognise some of these questions from BKSB because I've taken them all from BKSB today. Because, like I said, I would normally be there helping you throughout that learning. And that learning is really important to know that you've understood that. What I'm not going to go through is the skill check questions because I want to double check that that's our way of making sure you have actually understood it through the skill checks. So here's a BKSB question. Plan of a bedroom. Mario has drawn a plan of his bedroom on 1 centimetre square paper. His ensuite shower cubicle measures 1 metre by 1 metre. Give the scale of his drawing as a ratio. Anybody want to have a go at that? So this again is another scenario you could get where you actually have to identify the ratio used. This is a level 1 question from BKSB. Let's ask you this then. If his ensuite shower cubicle measures 1 metre, how much is 1 square worth on the plan? If his whole shower cubicle is 1 metre, how much would each of those squares be worth on the plan? Anyone? Let's see if I can draw it for you. What we got? I'll say it again. If his shower cubicle, let's see if I can do it this way. If his shower cubicle, I'm going to make it longer, is 1 metre by 1 metre in real life. So this is his shower cubicle. How many is 1 metre worth on the plan? Centimetres? So if in real life this is 1 metre in length, how much are each of these on the plan? If a full length is 1 metre, how much is that worth on the plan? Kim's got it. Chloe's got it. Well done. Yeah. If in real life his shower cubicle is 1 metre by 1 metre, so that's a square, and it's written on 1 centimetre square paper, in real life, each of those squares are going to be worth 50 centimetres. Yeah? Do we understand that? So that means that every 1 metre in real life is worth how many centimetres on the plan? No. How many squares is 1 metre on the plan? 2. Tasneem. Well done. Kim, well done. So, 2. Sorry, that's my fault. Let me write it again. So 1 metre to 2 centimetres. So every 1 metre in real life is worth 2 centimetres on the plan. Do you understand that one? Are you okay? So all you have to do is see which one you'd find the easiest. So if you can start with either side. If you find it easy to look at the plan and think, well, if that's 1 metre, which is what we're told, so it might be easy to start with a real life measurement. So 1 metre in real life is worth 2 centimetres on the plan. Not necessarily multiply by 2. I know it works out that way here, but I'll tell you what, we'll look at some of the questions on this particular drawing in a second, and you'll see how that might not quite work out. So if we have a scale of 1 metre to 2 centimetres, what are the actual dimensions of his bed in real life? And again, it's worth mentioning that this can go either way. So that is real life this time on the left, and that's the plan on the right. But you know which one because this is much smaller. So this is going to be the plan size, this is the real life size. So what are the actual dimensions of his bed? Well done, Kerry. Fidelia, that's right on the plan. Well done. Fidelia's got the length right on the plan, but what would that be in real life? And Tasneem as well, that's right on the plan. What would the real life dimensions be? So let me show you with that method that I just mentioned earlier. So let's look at the length first. So we know this time, we know the plan method, dimension, the length on the plan. So on the plan, if we look at the length first, his bed is 4 centimetres. Yeah, because it's 4 squares. So we apply the side that we know first. It doesn't matter which side we work on because we're going to increase it by the same amount. So this side, we've gone from 2 to 4. So what have we done to 2 to get to 4? We've multiplied it by 2. So what do we do to this side? We do exactly the same and multiply it by 2, which means that a bed that with a length of 4 centimetres on the plan is equal to 2 metres in real life. There you go. Well done, Tasneem. Let's look at the width. And again, for speed, when you get used to this method, you'll find you're doing this a lot, but you can rewrite this if you want. This is our sort of rule for this question. So 1 metre to 2 centimetres. So for the width of the bed is 3 centimetres. So this time we have to go from 2 to 3. So by how much have we increased that by? If you're not sure, do 3 divided by 2 to get the opposite of what you would multiply it by. But 2 times 1.5 would get you to 3. Because 1 is 2, half is 1 to get you to 3. So we multiply this by 1.5 as well to give you, because it's 1 times 1.5, 1.5 metres. So the actual dimensions of his bed are 2 metres by 1.5 metres. What do we all think to that question? Anybody need me to go over it again? Are you okay? The half came from when we looked at going from 2 to 3. So if you did it times by 1, it would be 2 times 1 is 2. But if we do it by 1.5, 2 times 1.5 So 2 times 1 is 2. 2 times a half would give you 1. So 2 times 1.5 gets you to 3. So that's by how much we've increased it by. Is that all right, Kim? And if you're not sure by how much you've increased it by, I've got a calculator here. You could do 3 divided by 2 to give you 1.5. Because 1.5 times 2 will give you 3. And that's your opposite. Let's do some more and see if we get, see if it helps. Right, what I'm going to do now, I need you to let me know if you can hear this. I don't know if it's going to work or not. If it doesn't, it's absolutely fine. I can even speak over it. But what I'm going to have to do is share my screen. Give me 1 sec. I can see about 3 of me now. Share my screen. I'm going to press play, but I'm just going to have to come back. Just let me know if you can hear this or not. Can you hear that? No, that's fine. My plan didn't work. Right, it's not a problem. Let me speak over it. So it's not possible to draw on paper the actual size of real-life objects like aeroplanes, buildings or cars, so we need scale drawings to represent these drawings. Scale diagrams use ratio to show this representation. If a diagram has a scale of 1 to 100, this means that for every 1 meter, 1 centimeter or 1 millimeter, the actual size is 100 times bigger. A scale can be written in different ways. It can be written as a ratio using the same units or as a statement using different units. So this is what I mentioned earlier. If there's no units given, you can use the same ones, and then it doesn't matter if you're using kilometers, meters, centimeters, millimeters. The size is going to be the same because you're going to increase both sides by the same. But sometimes you are given measurements which make them different. So it could be that 1 centimeter is equal to 500 meters. If you know the scale, almost it sometimes is easier the right hand side method than the left. So maps use different scales and are generally less detailed. They are often on a scale like this. I've never seen this on a practice test, but it's just to show you how scales can be represented on a map. So the scale on a road map is 1 centimetre to 1 kilometre, so we're given both the units there. And the actual distance between 2 towns on the map is 10 centimetres. What is the actual distance? If 1 centimetre represents 1 kilometre, then 10 centimetres must represent 10 kilometres. So do you notice there we've increased the map size by tenfold, so we increased the real life distance by tenfold too. The actual measurements of a room are 800 centimetres by 500 centimetres, and the scale is 1 to 50. To work out the length of each side of the plan, you divide each measurement by 50. This is another method. I'm going to stick to mine because you can listen to this one and repeat it as much as you can, and then it's important that you pick one that's right for you and that you understand in the best way. So what we would have done there, or what I'm going to do for the rest of these questions, if it's 1 to 50 and we have an actual measurement of 800, we would look at by how much we've increased 50 by to get to 800, for example, and it's 16 times. The same with the other side as well. But I will go through this with you. Right, is that okay? So that's just, I just wanted to go through the learning section with you, just to show there is a slightly different scenario, but it gives you exactly the same answer. And I want to show you this method and just compare it to the one that's on there, okay? Some of you might have watched that a million times already, but some of you might not have had a chance to see it yet at all. So here's a question from BKSB again. A scale model of a train is 1 to 30. So we've not been given the measurements, the units, sorry, this time. If the wheel diameter is 2 centimetres, what is the actual size of the wheel in centimetres? So it's told us what they want the answer in. We can write down our scale is 1 to 30. So every 1 on the plan, whatever that might be, is equal to 30 in real life. If we've got a wheel diameter of 2 centimetres on the plan, what's the actual size in real life? Does anybody want to tell me? Yeah, brilliant. I'll do this just in case anybody's not quite followed it as much as Chloe, Kim and Tasneem, which have done really well there. So if we know on the plan side, if we know the plan of the wheel is 2 centimetres, that means we've increased the plan side by twice as much, because remember with scale, we increase every single element by the same amount, okay? If we increase the plan by 2, we're going to increase the real life measurement by 2 as well. And because we're working in centimetres, 2 centimetres on the plan is equal to 60 centimetres in real life. Well done, Fidelia. Pam, well done. Kerry, you okay with that one? Emily? Sorry, I do get a bit behind on these. Yeah, Kerry's got it. Emily's got it. If I don't say somebody's name, please don't be offended. There's so many names. Sharon, are you okay? Yeah. Oh, good. Pam found it easy. I've started off nice, Pam. So we're okay with that one. I've only got 6 questions in this altogether, in the exact same 6 that were on BKSB. As I said, we're going to go through each of those 6 and do have different types of scenarios in the question. Then I want you to have a go at that skill check if you haven't done it yet. See what score you get. Let me know if you need help with any of those questions on there as well. So the scale diagram of a garden shows the length is 14.5 centimetres. If the scale is 1 to 150, what's the actual length in metres? So let's write down, I'm going to try not to waste too much paper today. I'm going to do this one here, is that okay? Just put a line under this one. So if our scale is 1 to 150, so 1 on the plan is equal to 150 in real life, whatever that might be. If we have 14.5 on the plan, on the diagram, what is the actual length in metres? Yes, I love this. This is girl power at its best. Well done, Halima, Fidelia, Pam. Nearly there. You've still got it in centimetres there, Pam. Do you want the answer in metres this time? So what have we done? The plan side, we've increased by 14.5 times. So we're going to do exactly the same to the real life side. So that's going to give us our measurement in centimetres, isn't it? Which is that. Now we need to turn that centimetres into metres. How many centimetres in a metre? Yeah, 100 centimetres in a metre. If we're going from centimetres to metres, we're going to divide by 100. It seems odd. We always do the opposite to what we naturally think, because we're technically going from a smaller measurement to a larger measurement. But if you remember, as in metres, we have a much smaller number. So we're going to divide our 2175 by 100 to give us 21.75 metres. Without a calculator, we could do that by moving the decimal place. Technically, it's there. If we divide it by 100, we move it twice to the left to get to 21.75. meters. Is everyone all right with that one? I'm trying not to go too fast, but I'm aware of the time as well. I don't have to go anywhere at 2 o'clock, but obviously I did advertise it as 1 hour. Yeah? Let's try a few more. If you're not sure about anything and you'd rather not say, it's not a problem either. As I said, I'm going to send you the recording. Have a listen in your own pace. Have a go at writing them down. Try and do this method with the arrows. If you get this method, by the way, you can then scale up and down on anything. You can do it in converting money. So if you had £1 is equal to 150 euros, how much is £5 worth? You increase that side, you increase that side, you've got your amount there. You can find, you'll be spotting ratio in lots of different things, and you'll be able to increase it by the same amounts. So let's have a go at the next one. So the distance between two distances on a map is 5 centimetres. The map has a scale of 1 to 50,000. Now this is the sort of question people look at and go, ugh, that's a huge number, 50,000, and the distance is only 5 centimetres. What is the actual distance between the two places in kilometres? Right, we've got centimetres first on a map, and they want the answer in kilometres. Okay, so let's have a go. You guys have a go as well. Let me know how you get on if you want to pop your answers in. I'll show you what. I'll start us off. Right, Fidelia, Lima, Tasneem, fantastic. Chloe, nearly. You've just got to divide it one more time. You just got too many. Yeah, exactly. You just need to convert again. And that's going from centimetres to kilometres as well. And same with Kim. Just need to convert one more time, but I'll show you. Well done, Chloe. Well done, Pam. Perfect. Does anybody want to tell me how they did that? What answer would you get first? So if we've got a plan length of 5, what we've done is increase the plan size 5-fold. So by 5 times. Yes, that's it. And then we've increased this side by 5 times. So 50,000 times 5 is going to give us 250,000. And at the minute, that's in centimetres. But they want it in kilometres. So what we would do, if you're not sure how to go from centimetres to kilometres, do it in steps. Do centimetres to metres, then metres to kilometres. So if there's 100 centimetres in a metre, we could divide by 100 first. And how many metres in a kilometre? Anyone? Yeah, 1,000. Kilo means 1,000. So if you're not sure, if you look at a scale like that or measurements like that, you think, gosh, I can't go from centimetres to kilometres. That's a huge jump. It is a big difference. But I would go from centimetres to metres by dividing by 100, and then from metres to kilometres, you would divide by 1,000, and you would end up with that. So if you divide by 1,000, you're going to end up there. Or if you know how many centimetres are in a kilometre, fantastic. But if you're not sure if converting does scare you a little bit, if you can remember those steps, you could go from centimetres to metres and metres to kilometres. I think that's quite a handy. If you haven't learned anything today, that is something you could take away with you. Right, everybody okay with that? Kerry, Sharon, are you okay? Yeah, fab. Pam's okay as well. Thank you. Okay, let's have a look. Let's go again. So a map has a scale of 1 to 250. 25,000. David walks 3 kilometers in real life. How far will this be on the map? Yeah, Chloe, that's right. It's understanding this scale bit. If you can do that, it's fantastic. Just make sure you've got the answer in the right measurement that they've asked for. So this one, we might convert in a different way. Let me show you how I did it. Because I've obviously looked through this and had a gander beforehand. So we've got 1 to 25,000. He walks 3 kilometers in real life. So that's 3. Sorry, is it 3 kilometers or 3.5 kilometers? I think I've written that wrong. Make that 3 kilometers, 3.5 kilometers, or we could do it on 3 kilometers. It's going to make it quite difficult, that with 3 kilometers. Yeah. Try and work that. This is my fault. I've just missed a 0.5 out there. This question, I'll show you, is this one. Oh, I'm not showing you it. Hold on. The question is this one. The second one. A map has a scale of 1 to 25,000. David walks 3.5 kilometers in real life. How far will this be on the map? It's important we do the 3.5 because the 3 is going to give us quite a large decimal when we increase from 25,000 to 300,000. So use that with 3.5 kilometers instead. So if he walks 3.5 kilometers, sorry guys, it's my fault. 3.5 kilometers. How many meters is that? No, it's not. It's the answer isn't in meters. Right, this question this question's got a bit awry. Right. They want the answer in centimeters. Okay, answer in centimeters. And the measurement is 3.5 kilometers. Okay? So if you want the answer in centimeters, is walked in kilometers. You either work this with kilometers or you work this in centimeters. Let me show you how I did it. So I went from 3.5 kilometers and I turned that into centimeters. So I went 3,500 meters because that's 3,500 kilometers. And then I turned that into centimeters. Times it by 100 to get 350,000 centimeters. So I converted into centimeters first. So I had a distance in centimeters. Halima's right. Well done, Halima. That's really, really good. So I had then my distance in centimeters, which is 350,000 centimeters. I then used this in centimeters. So if he walked 350 25,000 centimetres and the scale is 1 to 25,000, I would look to see by how many they've increased this by. You could do that by doing 350,000 divided by 25,000, and that would tell you we've increased it by 14 times. So we then do this side by the same amount times 14 to tell you that 350,000 centimetres, which is 3.5 kilometres, is the same as 14 centimetres. Which Halima got right, which I'm really, really, really good. It is a tricky question. I probably didn't help with that one at all because I haven't written this one out very well. I apologise. So the distance is 3.5 kilometres. The scale is 1 to 25,000. They want the answer in centimetres. So at some point, we have to convert from kilometres to centimetres. Now, for me, I converted here and I changed the distance that we were told into centimetres. I changed the distance from kilometres to centimetres so that I could then apply this in centimetres and it would all be in centimetres, including the answer. So I've got 350,000 centimetres is what the distance he travelled, which is 3.5 kilometres. Kilometres to centimetres you multiply because you're going from a bigger distance to a smaller distance, but the numbers are going to be bigger because you'll have more centimetres than you would have kilometres. So Tasneem said, wait, sorry, we divide 350,000 by. So if you're trying to figure out by how much you've increased by to go from 25,000 to 350,000, you're trying to figure out by how much you're multiplying by. How many of these go in that? The easiest way to do that is to divide 350,000 by 25,000, which will tell you the answer is 14. So then if you convert that, if you rework that in the normal way, instead of reversing the calculation, you do it normally, you could then do 25,000 times 14 will give you 350,000. Does that make sense? Because the opposite of multiply is divide. So if I want to know by how much I've increased it by, how many of these are in there, you could just keep adding these up until you get to 350,000, which would be 14. But instead, it's quicker to divide 350,000 by 25,000 to get the answer of 14. Fidelia, they did say the answer should be in centimetres. I just didn't add it there. But as I said, the answer is in centimetres. Let's have a look. 3.5 times 1,000 metres. Yeah, 350,000 in centimetres. That's right, Pam. I know that was a tricky one. And please go over this again in the recording if you don't understand it. Try it. Hopefully you've all got pen and paper and you're working your way through this as well. This is partly my fault. This question's not written properly. Let's try the next one. Right. There's only two left. John needs to produce a scale diagram of a bedroom using a scale of 1 to 40. The length of the room is 3.4 metres. What is the length of the diagram in centimetres? Any answers? It's not quite like that either, Lima. It depends on which measurement you're given as well, I suppose. So if we need the actual size, we multiply. If we need the plan size, we divide. Kind of. I don't think you could use that as a rule though, because it depends what measurements you're given and what units they're in as well, to be honest. Well done, Fidelia and Tasneem. 8.5. Let's have a look at this question then. So this time again, we've been given the length of the room in meters and they want the answer of the diagram in centimeters. So the scale is 1 to 40. We're not given any measurements here. The length of the room is 3.4 meters. What is the length of the diagram in centimeters? So we can either work this in meters or centimeters. I think I would find it easier in centimeters because with meters we have a decimal, and that decimal makes it, for me, might be different to you, but I prefer a whole number without a decimal so I can see and understand it a little bit more. So I would convert the 3.4 meters into centimeters. Is that okay? So it's 340 centimeters. I would then, let me get rid of the red because it's a bit harsh. I would then apply that to, so this is the plan, this is the real life. I'd apply that to what we know. Figure out by how much we've increased that by. We need to know by how much we've increased, we've gone from 40 to 340. So the easiest way to figure that out is to do 340 divided by 40 to give you 8.5 times. So 40 times 8.5 is 340. So because we've multiplied this side by 8.5, we're going to do the same to this side to tell us that 340 centimetres in real life, which is the same as 3.4 metres, is equal to 8.5 centimetres on the plan. Well done. Pam got it. Yes. Anybody have any questions with that one? So we were given it in meters. They want the answer in centimeters. So I found it easier to convert early and to work this as centimeters, because as I said, it doesn't matter how we work it. So first, yeah, you don't have to, but I find it easy to convert then, because I can imagine if you had 40 there and you had 3.4 meters, so 40 to 3.4 is quite difficult, because 40, if you work it in meters, would actually be 0.4, 40 centimeters or 40 meters. So if I convert early, I can say that this 40 is in centimeters, my 340 is in centimetres, and then I'm always in centimetres. Is that okay? I think it's easier to convert first, personally, and I prefer centimetres to metres just because of the decimal place there. It's much harder to see how many decimals go into another decimal than it is to see how many whole numbers go into a larger whole number, personally. Let's have a look. Last question. Now, this last one's a bit of a tricky one, but aren't they all? So, an architect is looking at plans for a new building. He notices the scale on the plans isn't very clear. He knows the length of the longest wall is 35 metres. And on the plan, this wall has a length of 17.5 centimetres. What is the plan to ground scale used on the plan? So what is the scale of this plan? So what do we know? Let's look at what we know. I mean, if you've got any answers, pop them in. But what I thought we could do is look at each scenario to see which one would fit and which one works. So we know that on the plan, if we look at the plan on the left, I don't know why, but I prefer to see the plan side on the left. On the plan 17.5, if we look at what we do know, if the longest wall is 35 metres, and the plan, this wall has a length of 17.5 metres, can anybody see a relationship to those two numbers at all? And again, this is where your multiplications come in. If you can start seeing numbers and how they work. Yeah, it's double. Yeah. Haliva's got it. She's fantastic at scale. So let's look at them individually then. So if we had, let's look at 2 centimetres to 1 metre. If the scale was 2 centimetres to 1 metre, we can input either of these measurements because we've got both of them in this example question, and we're trying to go backwards and figure out what the actual scale is. So if we input, say, the real life measurement, and I'm choosing this one because it's not a decimal. If we input this one, that means we've increased this by 35 times. So if we do the same here, that means that 60, 70. It will be 70 centimetres is equal to 35 metres. That's wrong because we know that 17.5 centimetres, let me write that on there, is equal to 35 metres. Yeah, that's great. If you can see those numbers and recognise it, it was going to help you out quite a lot. Let's look at the next scenario. So the next scenario answer is 1 centimetre to 1/2 a metre. So we could look at, let's pop our 17.5 in this time. So this time we're going to test it out with our plan measurements because there's a decimal there, there's one there as well. So either way. So this side, we've got our 17.5 times bigger on the plan. So if we do 17.5 times bigger this side, we're going to end up with 8.75 metres. So this is saying if that's the scale, then the length would be, on the plan would be 17.5, in real life it would be 8.75 metres, which we know is wrong because 17.5 on the plan is equal to 35 in real life. So let's try the last scenario, 1 centimetre to 2 metres. So let's have a look. We know that we've got 17.5 centimetres. Let's put the plan side in first. So we know we've got 17.5 centimetres on the plan. So that's 17.5 times bigger than the original plan size, the scale. So if we do 17.5 times bigger this time as well, it's going to give us 17.5 times 2, which is 35 metres. And that answer there is exactly what we want. So the actual scale of this plan that he has is 1 centimetre is equal to 2 metres. So that means that 1 centimetre on the plan is equal to 2 metres in real life. So did you see how we tested out each of those scenarios? This time we had the measurements. We knew that 17.5 centimetres on the plan is worth 35 metres in real life. But what's the scale of that? We know that looking at the relationship between these two numbers, the amount of metres is double the amount of centimetres. So that could have given you a clue there already. So the answer must be 1 centimetre to 2 metres because 2 is double to 1. But we tested out each of the scenarios to see if it worked. Because we had both measurements, we could use the different scenarios that we had and just choose which one of them we want to test out. So this time, for example, 2 centimetres to 1 metre, we popped in the 35 metres in the real life side. So we've increased that by 35. If we did the same to the plan side there, it told us that if we use that ratio, that scale, that would mean that every 70 centimetres is equal to 35 metres. Well, that's wrong because we know that 17.5 centimetres is equal to 35 metres. And we did exactly the same with this one and exactly the same with the last one. And the actual answer is 1 centimetre to 2 metres. How do you feel about that question? Are you okay? As I said, it might be worth going through it a bit slower in your own time. You can pause the recording, you can make your own drawings and actually analyze what you can see in your own time. Doing it in your own time is definitely an advantage when it's any form of maths, to be honest. Um, yeah, Chloe's going to go through this again. That's absolutely fine. This question kind of turned everything on its head a little bit. We had to find the ratio and the scale, and we were given two measurements. So he knew the plan measurement, he knew a measurement on the plan, and he knew a measurement in real life. So he had to go backwards to figure out what the actual scale was. So we tested each of them out. Yeah, go through it again. It's absolutely not a problem at all. And it's really, Kim, I agree, it's not my favourite either. I could do it and I understand it. And to be honest, I do quite like doing it, but it's probably one of the hardest to teach as well for me. Because everybody it's one of those that it's kind of like Marmite. You either get it or you don't quite. And sometimes I think this is the one for everybody that they have to work on more than other things. It doesn't click for everybody straight away, to be honest. Yeah, we can absolutely use this in real life. We use this, I go through this at level one and the introduction to scale last week. There's lots of different things we use scale for in real life, which is why it's in functional skills, because functional skills are functional. It's true to real life. So we can always apply all this maths that we're learning in functional skills to real life.